Let us discuss the syllabus of work, energy and power. The first topic is about the work done by constant force and variable force. Then is the kinetic and potential energies, work-energy theorem, power, the potential energy of spring, conservations of mechanical energy, conservative and non-conservative forces, motion in vertical plane, elastic and inelastic collisions in 1 and 2 dimensions. Let us talk about the basic concepts, important terms and formulae of work, power and energy. Work is said to be done by the applied force when the body on which the force is applied suffers a displacement in any direction except perpendicular to the direction of the force. Work is a scalar quantity and it is the dot product of force applied and the displacement, or F, the force into displacement into cos of angle between the force and the displacement. No work is done if the displacement is perpendicular to the direction of the force applied. Since work done is equal to F s cos 90, when the direction is perpendicular, cos 90 is 0. So work done comes out 0. This is the reason no work is done. If the angle between the force and the displacement is acute, then work done is positive. If the angle between the force and the displacement is obtuse, then work done is negative. Work done in terms of rectangular components, on resolving along its x, y and z axis, we will have fx sx plus fy sy plus fz sz. When the work done is positive, then there is increase in kinetic energy of the body. The next point is when the work done is negative, then there is decrease in kinetic energy. If the applied force is variable, then the work done is given by the integration of the small work done equal to the total integration of the force and the small displacement. Area of the force displacement graph gives the work done. Based on these two concepts, many numericals in the exam used to come. The next is about the absolute units of work in CGS system is erg and SI system in joule. 1 erg of work is said to be done when a force of 1 Newton displaces a body through 1 centimeter in its own direction. So 1 erg is equal to 1 Newton into 1 centimeter. Similarly, we can define the 1 joule also. 1 joule of work is said to be done when a force of 1 Newton is displaced the body by 1 meter in its own direction, and 1 joule is equal to 1 Newton into 1 meter. Next is about the gravitational units of work. In CGS system, these are gram centimeter, and in SI system, it is kilogram meter. The energy of a body is capacity or ability of a body to do work. It is of two types. Mechanical energy is of two types. One is the kinetic energy, another is the potential energy. Kinetic energy is the energy possessed by a body by virtue of its motion. It is given by half mv square, where m is the mass of the body and v is the velocity. This formula is valid for the velocities that are constant, but the formula is not applicable for relativistic speeds. The gravitation potential energy is the energy possessed by a body by virtue of its position in the gravitational field. It is given by mgh, where m is the mass of the body, g is the acceleration due to gravity, and h is the height of the body above the surface of the earth. According to the work-energy theorem, the work done by the force is equal to the net increase in the kinetic energy of the body. According to the law of conservation of energy, the sum total of energy remains constant. It means energy can't be created nor destroyed, can be transferred from one form to the other. Area under force displacement graph gives the kinetic energy of the particle. Based on that, numericals used to come in exam. The next is an important concept is of elastic potential energy of a spring. it is given by half kx square, where k is the spring constant and x is the displacement or extension of the spring. If the work done against a force is path independent, then the force applied is said to be conservative. If work done is path dependent, then the force is said to be non-conservative. The concept of potential energy is related only to the conservative force, means those force which are not depending on the path. So that will be concerned with the potential energy. Let us do the first question of the topic work. A force F is 20 plus 10y acts on a particle in y direction, where F is in Newton and y is in meter. Work done by this force to move particle from y equal to 0 to y equal to 1 meter is. These are the options given. This is on the page number 75 of NCERT New, and this question has come in the NEET National 2019. So, to solve this question, just remember the concept where we have talked about the force that is variable in nature, and the work done for that is given by the relation like this. According to this, it is moving in y direction, so we have taken dy here. Integrating will get the total work done, and the limits of the integration is from 0 to 1. The force is 20 plus 10y. So this is 20y plus 10y square by 2. So here the work done is equal to work done is equal to 25 joule. So now let us see the option. Option number B goes with the answer, and the answer for the first question is option B, 25 joules. Let us do the question number 2. A particle moves from a point minus 2i cap plus 5j cap to 4j cap plus 3k cap when a force of 4i cap plus 3j cap Newton is applied. How much work is done by the force? Options have been given, and this question has come in NEET 2016. So let us solve the numerical by the things that have been given to us. Particle moves from a point this to this. It means R1 is minus 2i cap plus 5j cap, where R1 is the first position vector. If R2 is the second position vector, then R2 is written 4j cap plus 3k cap. Now, the force this much is applied to it. We need to find out the work done. Work done is the force into the displacement. From these two position vectors, we will find out the displacement, and then we take the product of that with the force and we will get the work done. So, displacement is equal to R2 minus R1. So 4j cap plus 3k cap minus 2i cap plus 5j cap, and this thing comes out 4j cap plus 3k cap plus 2i cap minus 5j cap. So rearranging 2i cap, this is minus j cap, 4j minus 5. So this is minus j cap plus 3 k cap. So this is the displacement we calculated. Now for the work done, this is equal to force F dot S. So F is 4 I cap plus 3 j cap, and the dot product with the displacement S, that is 2 I cap minus j cap plus 3 k cap. I dot I 8, j dot j minus 3, no k dot here, so the value will be 0 and this comes out 5. So work done is equal to 5 joule. Now let us see the options, and it goes with the option number C, 5 joule. So the answer for the second is option number C. The third question. The force F is on the particle moving in a straight line varies with the distance d as shown in the figure. This is the figure given in the question. The work done on the particle during its displacement of 12 meter is, and the options are being given. This is on the page number 76 of NCERT New, and it has come in All India PMT 2011. So if you look at the question, this is a graph of force and the displacement, and we need to find out the work done on the particle during its displacement of 12 meter. So if we look at the graph, we have to find out the area of the force displacement, and the curve is being given by the solid line. So we need to find out the area of this part. In our concepts, we have already discussed this thing, that whenever the graph question is come, the area under the curve of force and displacement is going to give us the work done. So if we look at the area under the curve, this is a rectangle between 7 and 3, and the other part is a triangle. So the solution of this question is, first we write down the concept, area of force displacement graph is equal to the work done. So from figure, work is equal to, now for this rectangle, 7 minus 3 is the width and 2 is the height. So 2 into 7 minus 3 is the area of this rectangle. And then we have a triangle. The formula is half base into height. So base is 12 minus 7 and height is 2. So we will have 2 into 4 plus so it is 6, 4 to the 8 plus 5. So this value is coming out 13. So work done is equal to 13 joule. So let us see the options. The option number C goes with the answer 13 joule. So answer for the third one is C, 13 joule. Now let us see the question number 4. A body of mass 3 kg is under a constant force which causes a displacement S in meter in it, given by the relation S is equal to half 3t square, where t is in second. Work done by the force in 2 seconds is, and the options have been given. This question is on page number 74 NCERT New, and it has come in All India PMT 2006. So let us solve this question. This is a sort of numerical. Let us see whatever the things have been given. The mass is 3 kg. and the relation displacement and time is given to us, s is equal to half 3t square, and the time given to us is the 2 second, and we need to find out the work done. So for the work we have got the formula force into the displacement, and since force have not been given here, so we can also write down the force mass into acceleration and then the displacement s. So mass is 3 kg, so we will find out the acceleration by this relation. Since s is equal to half 3t square. Now differentiating this with respect to time, we will get the velocity. Again differentiating this with time, we will get the acceleration. So we got the acceleration, mass is being given to us, and s is also being here, where the time we will be taking 2 seconds. So work is equal to 3 into 2 by 3 into displacement 1 by 3 into 2 square. So this value comes out 8 by 3. So work is 8 by 3 joule. So now let us see the options. So if we look here, our option C goes with the solution. The answer for the fourth is C, 8 by 3 joule. Now let us take the topic number 2, kinetic and potential energy. In that, the first question is the potential energy of a long spring when stretched by 2 centimeter is U. If the spring is stretched by 8 centimeter, potential energy stored in it will be, and the options are being given, and the options are in terms of the potential energy U. This question has come in the NEET 2023. So let us do this numerical. Here, potential energy in terms of spring constant is given by half kx square. This is the formula. So, according to the first part, the potential energy of long spring when stretched 2 centimeter is U. Potential energy is U, and the stretching is 2 centimeter. So, 2 square. And if the spring is stretched by 8 centimeter, we have to find out the potential energy. So, one thing is there, because the spring is same in both the cases, so spring constant is going to remain the same, so this concept is to be used. So from here we find out the value of spring constant, that is 2u over 2 square. Now the potential energy when stretching is 8 centimeter, let u dash is the potential energy when spring is stretched 8 centimeter. So u dash is equal to half. In place of k, we will put 2u by 2 square, and x will be 8 square. So this cancels, and here we have 8 into 8 by 2 into 2u. This is, the value is 16u. So u dash is 16 times the potential energy when it is stretched 2 centimeter square. So answer for the question number 1 is option number C, 16u. So answer for the first is option C, 16u. Question number 2, the energy required to break one bond in DNA is 10 power minus 20 joule. This value is in electron volt, is nearly, and the options have been given. This question has come in NEET September 2020. Now, to solve this question, we must know how many electron volt are there in a joule. We have got the relation 1 electron volt is equal to 1.602 into 10 power minus 19 joule. Now from here we have 1 joule is equal to 1 upon 1.602 into 10 power minus 19 electron volt. And here it have been asked 10 power minus 20. So 10 power minus 20 joule is equal to 1 upon 602 into 10 power minus 19 into 10 power minus 20 electron volt, and this value is nearly equal to 0.06. So if we look at the options, our answer goes with the option number B, and the answer for the second one is option B. See the third question. A particle with total energy E is moving in a potential energy region that is denoted by capital U and it's a function x. Motion of particle is restricted to the region, then these options have been given, and this question has come in the NEET 2013. So when we are talking about the total energy, it is consisting of both potential as well as the kinetic energy. Since the motion of the particle, there is the motion in the particle, so we have to consider kinetic energy too. So for the solution of this question, the total energy E, this is equal to the sum of potential energy plus kinetic energy. So E is equal to potential energy have been given to us in terms of x denoted by capital U plus kinetic energy, that is also the function of x. Now from here we have E minus ux is equal to kinetic energy. Since the particle is in motion, since particle is in motion and kinetic energy is the energy concerned with the moving particles. So since particle it is in motion, therefore kinetic energy is greater than 0. If kinetic energy is greater than 0, then E minus ux, that is the total energy minus potential energy, that is also greater than 0, or E is total energy is greater than the potential energy, or potential energy is less than the total energy. So if we look at the options, our option number A matches with the result that we have got for the potential energy and the total energy. So answer for the third is A part. Now the question number 4, a stone is thrown at an angle of 45 degree to the horizontal with the kinetic energy K. The kinetic energy at the highest point is, and the options have been given. This question has come in All India PMT 2001. So let us go by the statement of the question. A stone is thrown at an angle of 45 degree to the horizontal with the kinetic energy K. So initial kinetic energy is equal to half m u square, and that kinetic energy is denoted by K. Mark it as equation number 1. Now at the highest point, when the kinetic energy is resolved into the components, then mass is going to remain the same, but the velocity will be resolved basically. So let Vx is the x component of the velocity, and that will be given by u cos theta, and the y component, that will be 0. So kinetic energy at highest point is given by half m u square cos square theta, or this is equal to, now this half mu square is equal to the initial kinetic energy and cos square theta. Since the angle that have been mentioned here is 45 degree, so we will be having it k cos square 45 degree. Cos 45 is 1 by root 2 and square of that. So 1 by root 2 square comes out to be k by 2. Now when we look at the options, so the result goes with the option A, k by 2. So answer for the fourth is option A. The kinetic energy at the highest point is k by 2. Now the next is the question number 5. Two bodies of masses m and 4m are moving with equal kinetic energies. The ratio of their linear momenta is, and the options have been given. This is on the page number 74 of NCERT New, and this question has come in All India PMT in 1998, 97 and 89. So the solution for this question is, there we have to connect two of the physical quantities, kinetic energy and linear momenta. Kinetic energy is equal to half mv square. So if we multiply and divide by the mass, we get this relation, or kinetic energy is equal to p square, square of momenta, upon 2m. So this is the relation between the kinetic energy and the linear momentum. Now there are two bodies, so let kinetic energy of the first body is p1 square upon 2m, and the kinetic energy of the second body is p2 square upon 2. Now this mass is 4 times this mass, so this is written as 4m, and this is equal to 8m. Now the kinetic energies of these two bodies are equal, so equate equation 1 and 2. Since kinetic energy of these bodies are same, so equation 1 is equal to equation 2. Equating these two equations, we get p1 square upon 2m is equal to p2 square upon 8m. And from here, p1 square upon p2 square is equal to 2m upon 8m. M cancels and 1 by 4. Taking square root both sides, we get p1 upon p2 is equal to 1 upon 2. So the ratio of their linear momenta is 1:2, and option A goes with our result. So answer for the fifth is option A, 1:2.